Okay. Previously, if you remember, when we were talking about converting to decimals, fractions to decimal, we talked about the different methods. Earlier on in the video, you saw the one that deals with division. So I have 5 divided by 8. The numerator becomes the dividend. And then you divide. You don't have enough. You just slot in the zeros and expand the place value into decimals. That's how one way. And then we talk about the other way of converting denominator into hundreds, tens, and thousands. Then the main question is, which one is better and which one works? And ultimately, the key thing you need to be able to remember is why one works better than the other. Now, and at the point of time, we understood, oh, because these numbers are factors of 10, 100,000, you can convert it this way. But if it's not a factor, and you have decimals that continue, then you either need a calculator to help, or you need to load long division like this. When it's not obvious factor of the tens, hundreds, and thousands. Okay? Now, that comes to fraction of a set. This was a recall for primary 4. And just before we left for the holidays, we talked about the 2 different methods. Number 1, the unitary method. I draw a model to see the whole is 9 and 3 units 9. So 1 unit is 3 and 2 units 6. So when I say 2/3 of 9, I can get 6 by the unitary method. Then I told you that, hey, if you look into P4, look back and revise your P4, you realize there are other ways in multiplication. So if you look at our textbook now, I'm on our textbook page 64 and 65. You see if you look at your textbook, I really find that, well, there are many, many ways I can choose to teach you. No matter is it online or through games. Actually, the most direct way is your textbook. It's something that you can refer to anytime. Okay? So please have it with you. Now, I'm on this page. Are you? Now, previously we talked about at primary 5, where is the upgrade in the demand and skills level? So we discussed about it and we say, oh, okay, actually the increase in demand and skill level is not just computing and solving the problem. Like yesterday, that one is really basic. That's why I was showing you yesterday when we did that. Yes. Yesterday when we did the conversion of metric units, that was really basic. And I really meant it that you got to be serious to realize that if you have trouble with it, it's really a big problem. Okay, and the best way to sort out those, practice. Practice enough. Yes. Now, where's the skills upgrade at P5? If you notice at P5, there are 2 main skills upgrade. Number 1, the first skill upgrade is most of all, in fact now, all of the problems come in the style of a word problem. There's a story that's presented, and then you have to apply the correct technique to find out the answer to the question. In the test previously, you realize a question can be confusing, can be solved by division, can be solved by fractions. Now, that's what is the first skill upgrade. At primary 5, I have to deal with more word problems. So a part of my maths calculation skills is good, my English must also be good. Because if I read the question, I don't understand, I will solve. I can't move on. So number one, most problems appear as word problems. So as the recall. So the recall is important. I'm not skipping it and tell you, oh, this page is not important. I'm asking you to look at it and realize that, hey, it's asking you to see, telling you to see that something that I learned in P4 still applies at primary 5. It's still important. And they show you how you can bridge the primary 4 learning to primary 5 by looking at the skills and the steps. Now, what is the second skills upgrade? The second skills upgrade is this. At primary 5, there's really more than one method to solve problems. In this particular problem here, multiply under the topic of the skill called multiply a proper fraction with a whole number. It comes from fraction of a set as an idea. So the skills to calculating are similar. Okay, now looking at this story here, there are 10 apples and oranges in the basket all together. Basically, it means 10 fruits. Okay, these are fruits. The first part to this problem is if you read and you don't understand. I like I told you, I was teaching a primary 1 class. We did addition. So we did numbers to 10. So the first statement is you also see it in primary 1. But what happened to my primary 1 boy? He thought for this first sentence, he thought it meant 10 apples and 10 oranges. You know what I'm talking about? Yeah. So my primary 1 child, he thought that they are all together, there are 20 fruits. Is that true? No. Correct. So this comprehension problem starts even from primary 1. Now, so the first thing you need to know is, okay, it means 10 fruits all together. Next, here comes the fraction. 3/5 of the fruits are apples, and how many apples are there? So you know all fruits will mean the whole. That's the whole. And then among all fruits, you have 1 part apple, 1 part orange. So this is like the papa whole ideas from primary 1. Already you start learning that before. So there's the fraction here. We go back to it and talk about it. In a fraction of a set, you have the whole, or in the set, you have I want this part and the total number of parts. So come back to here. It gives you 2 methods. The first method says in the unitary method. So saying that 3/5 of the fruits are apples, it will mean that, okay, I can group the fruits into 5 groups. 5 groups like this. And out of these 5 groups, 3 groups are apples, 3/5. There are many methods I can solve this. First, I can look at 3/5, and at primary 4, I will have learned this before. Okay, I'll show you another method that's not in the book, okay? Because I know equivalent fractions, I can convert this into the equivalent fraction whereby the denominator shows me the total number of fruits. Do you know what I'm talking about? And then say 6 of 6 is an apple. You know what I'm talking about? Now, well then, this book presents it method 1, the unitary method. 5 units is 10. I find 1 unit, so 3 units is the one that I want. That's 6. Now, why is this method not shared here? Anybody? This method not shared here. Converting to its equivalent. Yes. Different level. What do you mean different level? Sorry? P4 method. But is it still useful? Yeah, and so it's still useful, right? Now, when we look at another example, maybe it'll become more obvious why this method is not often used. Okay, then we look at another one here. This is the other method here called the cancellation method. If you look at it, the word cancellation has inverted commas, right? Means that it's like sounds like it's cancellation, like you minus, but actually it's not. Remember in the previous topic we talked about times and divide by multiples of 10,000 hundreds. Then we have the cancel as well. Sounds familiar, right? But we don't really cancel. We stop cancelling. But the action itself is cancelling. So exactly what are we doing here then? If it's not cancel. Yeah, it's what you do, right? If it's not cancel, what is the strategy that is being used here? Yes. Same as above. A timetable. So what exactly is this? Is here already. The cancellation simply means it's trying to show you division. Very good. Atisham, well done. Now, the idea of this division is I can simplify my steps. So I can do cancel, meaning I do 10 and then divide by 5, and 5 divided by 5 is 1, and then you have 2, and then that's it, 3 times 2. In other words, actually this, does it look very different from this? Not really. Basically, it's just a different way of showing it. But this can be taught as a shortcut. Now, there's another way of presenting this. Okay? For example, I can do it, some of you do it this way. 3/5 times 10, right? Some of you may have learned from somewhere they ask you to just put a denominator like this. Does it look familiar for some of you? Yeah, why does this go? Remember, I always tell you, don't just, I thought I learned this, I did, then I get. You need to know why. And once you know why, you remember better action. Why? 1 hole. So actually, when you do like that, how many holes are you looking at? 10 holes. Very good. So 10 holes, and I could do this without being confused. Easily, right? Now, I can also do it in another way. Same steps as this one is. What I can do is, I can do the numerator times and the denominator times. And then 30 times 5. Anybody learned this one before? Numerator times divide, and then divide then the denominator times. Anybody learned that before? Okay. So I have 3 times 10 and then divided by 5 times 1. I got 30 divided by 5, that's 6. All this also give me 6 as the answer. Anybody learned these things before? Okay. Now, as you can see, Miss Lim is aware of all the different methods. The next question is, which one is the best then? Okay, who said I like this one? Unitary. Who said I like this? Cancel. Who said I like this one? Who like this one? Okay, how about this one? Okay, now the next question, why? Who said this one? I like this one because like can understand better. Okay, who said I like this one because look like the shortest I like shortcut. Okay, good. Okay, now then I must tell you, as a teacher, right? I tell you I know all the methods, right? As a student, right? If you know all the methods, that's also very good. In fact, it's necessary that you know all the different methods. But what's the most important thing? One method may be better than another method depending on the question. You know what I'm talking about? Let's say, for example, I look at this one here. This is page 73. I'm looking at F now. Okay, I'll show you some examples, okay? This is 73, looking at F now. Now, For me, if I want to do it fastest and easiest, okay, are you at 73? Yeah. If I want to do it fastest and easier, I will choose number 1, I cancel the 0. Then 15 times 9. Okay. Okay, can see, can see. Now I skip. I move faster. Got to be a bit faster. Yeah. Now I skip to this question, page 72, question number 4. If you look at this question, which method do you think I will choose? Someone said unitary. Who is it? Why? Will I use the cancel method? Shortcut, the shortest. Yes. It's review. Check your bag. I gave it to you last Thursday. Together with your test paper and together with your holiday homework. And I told you clearly that you do the first page. It is page 72. Now, see we say use unitary. Don't use the shortcut. Why? The shortcut, do you think it will work here? So I do 47 times 32. Is it like this? Is this like this? No, something is wrong. Cannot do this. What? What do we need to do first? What do we need to do first? Sorry? Raise. Very good. So we say, remember, first thing you must do is to read. So obviously, if you never read and you want to put in some simple, no matter it's time multiplied, you are stepping into danger zone. Danger zone is big mistake. Okay? So read. You already read. Show your proof. Here says 4/7 of the puffs are made that Mr. Tan made were curry puffs. The rest was sardine puffs. Mr. Tan made 32 curry puffs. How many puffs did he make in all? If you have read the question carefully, you will realize that 32 is what? Is it all the puffs? Only the curry puffs. And then your friend said, yeah, it's only the 4 units. Here, 4/7 of the puffs. So how many puff is all the puff is how many units? 7. How do I know? Because I look at the denominator. The denominator says it all. So I should have 7 units. 1, 2, 3, 4, 5, 6, 7 units. So 7 units is in all. That means all the puffs. And then 4 units are curry. In this case, the rest is how many units? The rest means 3/7. It means 3 units. So I could write down 4 units is 32 puffs. So 1 unit is 8 puffs. So 32 divided by 8 is 8 puffs. And then so in all is how many units? 7 units. So 7 times 8, right? Then how many puffs are there? 56. Can you understand? Now, in this question, with regards to fraction, this method is the best. the unitary method. You understand? So in the end of the day, what is difficult about P5? The most difficult thing about P5 is not learning all the methods. Is which method should I use? If I only have one method, do you think it's enough to solve all the problems? No, that's not going to be enough. Okay? You need to know more than one method. So you know which one can be used. If I use the time sign cancel just now, will you work? No, you will not work with this one. So it really depends on the question. Okay? Okay. Now, so just now we saw many examples. What is another example here? So just now we saw these few examples, right? We have this one, we have this one, we have this one, and then we have all these. So first thing we already decide which one is a better one, right? In under which situations, right? Okay, then how about this one here? It looks longer. Some of your friends say, this shortcut, use a shortcut can already. How come this one? When do we use this then? You may not have a good example in yours. Okay, I will say, yeah, look at this one. This is page 74. Already got some example here. Okay. Let's look at E. This 5 times table is one of the easier times table. This is page 74. E. This one, can I use unitary? Is it a method for this one? Question 74E. Can unitary method work? Can or not? This one, F is page 74. E. Page 74, E. Page 74. Page 74. Yeah, page 74. Yeah, right. E. Can you use the unitary for this? Can I? You sure? Why can and why cannot? Can I do cancel here? Can I do cancel here? Why cannot? Apart from the zero, I think if you're talking about cancel, okay, I'm at 73. Let's try another examples. Okay, another 2 examples. I'm back at 73. I'm back at 73. I'm looking at 73A. Okay. I'm page 73A. For this one, I choose cancel. Okay. It can cancel. Okay or not? Again, the skill here is called multiply proper fraction by whole numbers. Okay. Now, for this one, I choose cancel. Okay. Some of us may like to write it this way: 24 wholes. So that it's less confusing. Cool with that. Okay, go ahead. All right. Choose cancel. A reminder: when you do cancel, your working must be very clear. Okay, if you're working not clear, you might make mistake easily. How fast did I do this? Less than 10 seconds, right? Now then you should be able to answer me. Okay? How come this one cancel can? Right? Can cancel? Can you understand why cancel? Why cancel? I simplify, I'm doing division. So basically, I'm doing 8 divided by 8 and 24 divided by 8. The division. And can you see how important your times table is now? So your times table no good, you better practice this hard. Every day in the timetable song. Okay? Now, this is page 73, question A. I use cancel here. Okay? Page 74, question E again. Can I use cancel? Cannot. Why cannot? Sorry? Because 34 cannot be divided by 5. Can you simplify this? Can you divide it on the timetable? Cannot. Now, where is the clue that tells you that cannot divide by 5? Apart from it on the timetable. Very good. Jun Hong say, hey, look. Don't forget to read the question. The question says, give each answer as a mixed number in its simplest form. This is the biggest clue that tell you, oh, cannot cancel. So cannot cancel, I must do it diligently. I'm back at here at E. So I cannot cancel, I do 2/5 times 34 wholes, okay? Then I will do 2 times 34, that gives me, what was it? 68. 68 will be 5. Now, some of us will prefer maybe the additional step. I'm very scared I made mistake. So I do the extra step of writing the numerator times numerator, denominator times denominator. Okay? Okay? And then I do 68 and then this. What would this be? 13 3/5. Okay, how can I check this? I use division. 68 divided by 5. So 1, 5, 1, 18. Okay, is this correct? And then I do 3 minus 15, 3, 13 and 3/5. Is it okay? Then we come again. Hey, this step looks very familiar. Some of us may learn it. Why did your teacher teach you this long, so-called long method? Must have reason. Right? There must be a reason. Sorry? Okay, first of all, we already established. First of all, we agree that when numbers are not multiples, are not nice numbers, it doesn't work so well. Okay, so I need to do the longer step. Cannot cancel. Now, then there's this numerator times numerator, denominator times denominator. So very good. Where will I use it again? Okay, you remember to this question in mind. Okay, we will be looking at this one very soon. Just in the next unit after this. Where will I use numerator times numerator, denominator times denominator? Anybody want to guess now? When it's a mixed number times, what was this Q? This Q is proper fraction times whole number. Okay. Just now, Samantha said, I maybe need to use this numerator times numerator, denominator times denominator. Which Q do you think will be next? In your textbook, why don't you just pick one more page? Next number times 4. So very possible. Yeah, you're right. That's the first part. That is called converting a mixed number to an improper fraction. Then you times with a whole number. Not saying you're right, but not that quite right still. What do you think is even more after that? Fraction times fraction. Very good. Okay? Multiply a fraction by a fraction. That's the thing. Multiplying 2 fractions. That's what we will be learning very soon. Okay? Alright, Ken, back here. Are we okay? Still surviving? Is it okay, manageable? Okay, I'll let you have a choice now. We have 10 minutes left. Would you want me to go through the word problem with you or let you try this by yourself? Okay, then I let you try 72, this question. Hey, 71 considered you should have finished already, right? I remember writing, circling this page and telling you homework, holiday homework, first page. Okay, now 72 and 73 do now. 72 and 73. 73 done. Very good. Okay, 72, 73. So we are looking at 71, 72, 73, and 74. Is that okay? 71, 72, 73, 74. Is that okay? Okay, then tomorrow we will be at the learning. Okay, on Thursday when we come back, we will finish up this portion on the word problems and start the next challenge that Nosi say mixed number times whole number or improper fraction times whole number. Okay, do now. 72, 73. Who's finished already? 72 and 73. Not yet. Okay. Okay, the one that is finished later will come out and present answer. Yes, I one question only. I already did one for you. Now, that one problem over there, are we all like done with the first one already? Not yet. Okay, some of us are struggling. Okay, take a moment. Okay, never mind. We do together lah. Okay. 1/4 times 60. Which method is the best? Cancel. Okay. 1/4 times 60. Cancel. Okay, 4. Quite quick, right? Okay. This one, 3/5 times 50. What's the best method? Also cancel, right? Okay. So that would be 9. Quite fast, right? Okay, this one. Do you want to do cancel? Yeah, possible. Oops. So I times 560. I can do cancel first. So 560 divided by 8. 70. Okay, so it's 70. So 70 times 3, 210. Okay? And then 7, 9 times 2, 7, 9, 279. At this stage, some of our friends might feel, yeah, just multiply first, then divide. Actually, and then it's okay, also works. Some of our friends say, maybe I try divide first. See whether can. Can I try? Divide by 9, 3, 27, 31. Okay. Oh, actually can. 31. So 7 times 31. 207. Okay, done. Okay, is it okay? Okay, now I move on. Okay. I'm recording this, so if you can't catch up, you go back and tell. Okay, can? Okay. Now, collection of 36 pins, 6 are red, and the rest are black. Okay, doing my race here. Now, then how many black pins does Janice have? Now, I go into my race steps, and the race steps help me to decide later which method is the best. Okay, just now I was able to tell you cancel doesn't work because I know the question already, but I pick the question. Then you have to think why it doesn't work. So Ziwei tell you, hey, look. The reason, because you must start with reading first. Don't forget to read the question. Once you read the question, then you realize, oh, what is given and what's not given. Then it will point to you which method is better. So I do the reading diligently. Do I have all the pins? All hairpins. So the story is they are all hairpins, and then some black, some red. Is it? Okay, correct, right? Is this make sense? All pins, all hairpins. There are some red and some black. Which one is given? Red is given. Okay, red is given. Is black given? Black is not given. Black is the one that you need to find. All pins, is it given? All pins given. All pins 36. So which method, look at this. Which method will I choose? I can do the unitary. So I can do the unitary. How many units is it? 6 units. So because I look at the denominator for the rate. So 1, 2, 3, 4, 5, 6. 6 units. 6 units is all the pins, 36 pins. 1 unit is red. That means the rest is black, right? Correct. So if I use the unitary method, 6 unit is 36. 1 unit is 36 divided by 6. What's that? 6. Okay, so how many units do I need? Black is 5 units. So 5 times 6 is 30. But I can do subtraction as well. I can just use 36 minus 6. Now, for me, because I know there's a fraction given, 1/6, right? That means for me, I will just know 1/4 and minus the fraction of black is 5/6. So for me, if I really choose, I will do the cancel actually. See? Also work. Well, so for this particular pressure on the hairpins, it's really your preference. I think both are quite fast. It's only how well trained you are in the method. If you're somebody at home, daddy, mommy train you to do unitary, your unitary must be better than other people. But if your tuition teacher train you and push you and make you do 100 questions on this cancel method, then maybe your cancel is better. Okay? But if you are a student of Miss Aisley, then Miss Aisley will tell you, you should be expert in every method. And the best expert here is you know which method works best and under what situation. Not exactly an expert too. I'm also learning. Yeah. All right. If I'm an expert in maths, I'll be a mathematician. Yeah. Yeah, professional maths creator. Yeah. No, it's not that. It's not. I choose to teach the subject. My expertise is teaching. I know what will be a useful way to teach. My expertise is not mathematics. Like Han say, I design a new way to count things, an alien method, a new number, not called number, called number, a new numeral system used by the alien. Yeah. That will be a true mathematician. Huh? After school, right? Wait, haven't. Let me finish first. Okay. You pack your bag first. Pack up your things. Hey, please, you go back and check on this. Okay? Pack up your bag, please. Okay, are we cool? Okay, okay. Wait a while. Okay, don't pick up our friend as well. They're going for a workshop in another school. Okay. Okay. Ken, is it okay? Yeah. Okay. Is it okay? Now, do you need help with the rest or can you do it by yourself? Okay. You try this as homework, shall we? Okay. On Thursday, when you come back, you already do that very good. Then you try the work problem as well. Okay. On Thursday, we will finish up with the work problems and this set on proper fraction with whole number. Then we will start off with improper fraction. By the end of this week, we must reach fraction times fraction. Okay, Ken? Is that okay? Sorry guys, today not enough time to take the computer and play the game. Okay, never mind. But I think we accomplished quite a bit today. Is everybody okay? Clear about the homework? Okay. Then last 2 minutes, play the video for you. Which one you want to see? The B5K one. Okay.